This is question 7. I rank this question as intermediate level, including checking time. It will take you maximum up to 10.5 minutes. So the calculation is, I get the total mark here, 3 and 4, which is 7 marks. 7 marks multiply 1.5, gives you 10.5. So this is how I get the 10.5 minutes. This question is about the correlated rates of change. So before I start, I would like to have a recap of this question. I would like to have a recap of correlated rate of change. For the rates, we have actually 3 major types. First type is constant rate. Constant rate means the rate is constant throughout the entire time, and it is independent of change. Second type is instantaneous rate, and it is a function of time. Instantaneous rate change with time and is not constant. Third type is average rate. So in general, we have these 3 rates. Okay, so as per usual, I will underline the keywords of the question. So let's take a look at the question. When the hemispherical ball above, which is this one, contain water to a depth of x cm. So this is the x cm. The volume of water, so this is volume of water, is given by this formula. Okay, pause here, and usually I would like to transform all the information, the important information, into my questions. Easier for me to visualize. So we have the water volume formula. Let me write down. So this is the information I obtained from the first sentence. Next, let me continue the second sentence. The question says, the ball is initially empty. So initial means T is equal to 0, then empty, so means the volume is 0. So I will write down T0 equal to 0, and V0 is equal to 0. So the 0 here actually, the 0 here, it just denote that they are actually a pair. Means that when T equal to 0, B equal to 0. So easier for us to pair it together. Okay. So let me continue. After water has been put into the bowl at a constant rate, okay. So pause and think. It mentioned the water has been put into the bowl at a constant rate. So this constant rate referring to what? This constant rate, because it's the water being put into the bowl, it means that the dVdt is constant, because water is actually put into the bowl with a constant volume, right? So this is what it means, constant rate dVdt. Okay, for 9 seconds, so T1 equal to 9, you will get the depth of water, x1 equal to 4.5. So same thing, I write down this information. So it means that we have T1 equal to 9 seconds. Our x1 is equal to 4.5 cm. Okay, so I obtained the I write down all the key info I need. Then now I can go to the question. So question part A, it has mentioned that ask you to find the constant rate of the volume. So this is what we want to find, which is the dBdt here. So they want to find out the dBdt. So in terms of pi. So, okay. So to find the constant rate, as I mentioned earlier, it is constant throughout the entire time. So it means that to find the constant rate, the definition is the change in volume divided by the time taken. So since it's actually the change in volume then over the time taken, you can actually consider also writing in another way that we have dV1 minus V0 divided by T1 minus T0. So this is the formula you can use for the constant rate. So let's check, do we have all the information we need? We have the T0, so this one okay. We have T1, so this one okay. We have V0, this one okay, but we don't have the V1. So we need to find our V1. So V1 again is actually corresponding to this pair. So we need to find out what is V1 So okay, how to find it? Do you remember we have this formula? Yeah, so we can actually apply it. So to find V1, we can apply the equation. V1 is equal to 1/3 pi. Okay, so you sub the x1 in. So the x1 we have is 4.5. So you can sub the 4.5 into it. And you can do the calculation. So you will get V1 is equal to 729 pi over 8. So cm². Okay. So after we have found it, we can now apply the formula to find out our dBdt. So dBdt is equal to V1 minus V0 over T1 minus T0. Can sub the value we have known here over, so T1 9 seconds minus 0 here, and then can leave. Yeah. So the question mentioned in terms of pi, so we have to leave our answer in terms of pi here. So this is how we do the constant rate. Next, let's go to the part B. Find the rate at which the water level is rising. So water level, remember, water level is denoted by dx dt, but by dx. So the question here is asking you to find the dx dt. And it has mentioned is rising. So it means that we expect that the dx dt has to be more than 0. And okay, you see this is a keyword you need to take note of. When the depth is 4.5 cm, when this is x1, remember? So when the question mentioned when the depth is 4.5 cm, you might pause and think this usually means that the rate is not constant throughout the time. It means this could be the instantaneous rate. So when you actually want to do the instantaneous rate, you have to apply the connected rate of change. Okay, so we have gathered the information we need now. So the question is asking for the dx dt when the x1 is equal to 4.5 cm. Okay, now we can apply connected rate of change to do the question. So how to apply connected rate of change? A lot of students like to ask me about this because they have a difficulty to form them. There's actually the time of rule. Maybe you can think of how many variables do you have in this question. So you can scroll back. Of course, look at part B itself. we already noticed that we have a variable x, we have variable t. And if you scroll up a bit, you can notice we also have a variable v. So that means we have total 3 variables in this question. So this 3 variable means that it will contribute to 3 terms in your coordinate value change. Yeah. So 3 terms means you will have coordinate value change. Okay. You will have something equal to something times something. So this is what I mean about 3 terms. So of course, how will you actually put them in? I will see the v here as the majority of, because we can see earlier the v in terms of x. So we will actually put the v here. So we have dv, and we have actually from the previous part we have our dv dt already. So we can just write the dv dt here. So after you write this one, you confirm the dv, the left hand side. We can come to the right hand side. So how to actually position that? I will put the dv here. Okay, so can make it, and then I put the dt here. Okay, so what to fill in? Remember, we have 3 variables. So the last one is the x here. So I will put the dx dt. Yeah, dx above. So you can fill up the gap now. So technically this is not true, but you can actually see it something like, if you cancel these two, because they are actually like one numerator and the other one is the denominator, you can cancel them out. You will then get this dv over dt, which is same as what we want to get. So this is just a unconventional method to actually find to form the coordinate value change. But it's not true. It's not true that this is how it works. But then you can actually visualize this way. Okay, then now we back to the question. So after you form the coordinate value change, right? You have to think, okay, bear in mind this is what we want to find. So, and we have to see, okay, do we have the dv dt? If you scroll up, yeah, you have a dv dt here, right? So this is what we have. Now dv dx then, are we able to find the dv dx? So remember, we have actually this one. We have our v in terms of x, so we can actually utilize it to find our dv dx. So let's copy this equation. So we have v is equal to 1/3 pi x squared 18 minus x. So let me double confirm here I copy correctly. Yes, it is correct. Okay, so after I write this, so now I'm going to find the dv dx. So it means that I need to differentiate this equation. So with how to differentiate this equation now, take note that 1/3 pi is actually a constant which you can always leave it in front. Okay, so just copy it. Now you also notice, right? This is 2 terms. So we will have to apply product rule. We'll do the differentiation. Okay, so I put a bracket here. So we can actually perform the product rule. The product rule is we can, first term, the x squared, we can differentiate it, and we keep the second term, which is this, plus you keep the first term, and you differentiate the second term. So differentiation on the second term, because 18 is a constant, so it becomes 0. Negative x, it becomes negative 1 here. Okay, so this is how you do the differentiation. So now let's simplify the entire equations here. So we have sorry, I have to change the bracket to the wrong one. So yeah, simplify further, we will get, so we will have games. So they are all having the common factor of 3. You can take out the 3, and then you will have 12x minus x squared. So we also have x as the common factor. You can take it out. So okay, so this is our dv dx. But don't forget, we have to find the particular moment when the x1 is 4.5. So what is the dpdx? So when the x is equal to 4.5, our dpdx is equal to pi, and you sub the x value. Okay, then you do the calculation. So I get the answer is this. Okay, so now I get the dvdx at the particular moment when the x is equal to 4.5. So I can sub all the, I obtain both the all the information already. We can actually now apply sub all the value into it. So when x is equal to 4.5, our dv dt, copy the collateral change omega film. Okay. So the dv dt is a constant rate, remember, is this value. So I just copy it and write here. 81 pi over 8 is equal to the dv dx we have found here. Multiply the dx dt. So rearrange them. Simplify, you can get the dx dt is equal to 81 over 2. You simplify the answer, you will get this. Okay, so the last step, after I'm done, I will check the unit. I will check the unit. So bear in mind, the unit is needed in this question. So yeah, I have it here. So I scroll back. Okay, this one I forgot to write the unit. This one. So I will have to write the CME of unit. So it's actually the same square. And then scroll back. Okay, so this one is the same thing. I mean, for the answer, for the value you have found, you have to find it. So this one is okay. And the part A, I have it here. So that's fine. And I have it here as well. So yeah, always check the units. Bear in mind, always check the unit. Okay, so this is how you do the question.